Hello everyone. In this session, we will go through the topic of the simple linear regression in RStudio. And you can find the supporting material on the page mystats.online, and the data for the exercise coming from the R book are also located on the webpage mystats.online. The regression is the basic statistical tool or methodology, and it's really old. So coming somewhere from the 18th century, and the methodology of the least squares. The main purpose of regression is to explore and estimate certain behavior and also to predict or forecast values. So if the response and explanatory variables are continuous, and if we only have one explanatory variable, then the regression is called simple linear. So let's try to read the file and explore the example we have here. So you can open or you can read the file tannin and save it into the object tannin. I have saved my file into the folder with documents. Read. And let's have a look. How does the file look like? So let's view the file tannin, or let's view the object tannin. And we can see we have two variables. The first is the growth, and then the explanatory or independent variable tannin, which stands for the concentration of the tannin in the diet. And we can see that if the concentration of the tannin is the lowest, then the growth is the highest, and if the concentration of the tannin is the highest, then the growth is the lowest. So it says that, or we can expect the decreasing trend, but to be sure, we can certainly plot the graph. So let's plot the dependency, growth, and tannin. Theta equals to tannin. And let's create our linear model, and let's save the result into the reg model. So reg model stands for LM, dependency of growth, and tannin, where the data are equals to tannin. Let's have a look. How does our regression model look like? You can see that the intercept we could fit into our linear regression formula, epsilon equals to a plus bx. So A, which stands for intercept, would be 11.756, and B, which stands for slope, would be minus 1.217. Let's draw, or let's paint the trend line across our graph and across our points by function AB line. AB line, reg model, regression model, color green. And on the green line, there are our predicted or fitted values. So fitted, we can create the object fitted, and there we can save our predicted values on the green line from the model reg model. If we wish, we can display these fitted values and see how does the exact values on the green line look like. Again, we can paint the differences between the exact measured values, exact points, and the green line. So for this we can use the loop, for example this one in the middle, and from the first to the ninth to the last observation, let's create a line and a line between the exact point and fitted green line, and let's make these lines red. Okay, so these are our residuals or residual errors or differences between the predicted and measured values. More information about our regression model can be obtained by function summary. So summary reg model. Here we can see again our intercept and our slope. We can see also the levels of the standard error, t statistics, and p value. So based on these numbers and based on the p value, which is extremely small and much smaller than our desired confidence interval 0.05, we can already say that our fitted green line is very good fit, because p is much smaller than 0.05. As confirmation of our approach, and obtaining also the assumption for the linear regression, we can create or we can plot classical graphs built in our studio for normality, conformation, and residual dependencies. So let's prepare the screen to 4 sections. Par mfraw equals to c2, 2, and let's plot the regression model we have generated. The most interesting for us is the top left graph, residuals versus fitted, which should look like the night sky full of stars, and there shouldn't be any trend, because if there would be some trend, the fit of regression model wouldn't be good enough. And top right graph is displaying on the other side very nice normal trend, linear trend line, which is a confirmation of normal distribution, which is another assumption for the linear regression. So that's it, basically, the most important part or most important information, how to create a linear regression, simple linear regression in RStudio. And thank you very much for your time and attention, and I hope you will attend the next session again. Simple linear regression.